All right, so let's get right into it. This collection of sources you've sent me about magnetic motors,
Mm,
it looks like some pretty fascinating stuff. We've got patent applications,
right.
scientific papers,
Yeah.
and even a YouTube video featuring an expert.
Uh,
So we're really going to dive deep into these motors that supposedly run on nothing but magnets.
it's definitely a topic that I think sits on that line between like established science and
Yeah.
and I
Yeah.
hate to say it, but fringe theories.
Exactly. And that's what's so interesting. I mean, on one hand, we've got like classical electromagnetism, which pretty much says a motor can't just run on permanent magnets.
Right.
It defies the laws of
Yeah,
thermodynamics.
you can't create energy from nothing.
Right, like perpetual motion.
Exactly. It's this idea that's captivated inventors for centuries,
Yeah.
and it always runs up against those limitations of physics.
But then we have these patents like the one from Malafea in 1989.
Oh, yeah.
And he claims to have cracked the code. He describes a motor with rotors and stators, and both of them are loaded up with magnets set in these like angled sockets.
Interesting.
And there's this detail that I thought was really interesting.
Okay.
He specifically says that the magnets should not be fixed rigidly.
Uh-huh.
He wants them to vibrate a little bit during operation.
And that's the detail we also see in another patent
Really?
filed by Brady in 2006.
Okay.
His design is very similar to Malafy is also using those angled sockets, focusing on a small gap between the rotating parts.
Wow, so decades apart.
Yeah, and what's fascinating is they both highlight using these ferromagnetic linings within the sockets, almost as if they're trying to like shape and direct the magnetic field.
It's like they're not just relying on the raw power of the magnets.
With
You're
exact,
trying to create a very specific magnetic environment.
yeah,
And the fact that two inventors decades apart landed on such similar designs makes you wonder if they were onto something.
absolutely. And that's where the work of Dr. Jorge Duarte comes in.
Oh.
He's an electrical engineer who's really gone deep into analyzing these types of motors.
Right, I saw he published papers and even appeared in that YouTube video we talked about.
Exactly.
So how did he even begin to approach this? It seems like it'd be a real head scratcher to analyze something that defies the laws of physics.
Well, he started with a solid foundation
Okay.
in classical electromagnetism.
Oh.
And he modeled these motors by representing the permanent magnets as equivalent current loops.
Okay.
It's a technique based on something called Amperian currents,
Mm.
which essentially lets you mathematically translate the magnetic field into something you can calculate.
So he's basically creating a mathematical model to represent all the complex interactions of the magnets in the motor.
Exactly. And what's remarkable is that when he applied this model to the arrangements described in those patents,
Mm.
his calculations initially suggested that a very specific magnet configuration could actually produce a net positive torque.
Oh, wait, you're saying his calculations showed that these motors could, in theory, generate energy out of thin air.
That was the initial finding.
But that goes against everything we know about physics.
It definitely raised eyebrows.
Yeah.
But in a later addendum to his paper, Duarte revisited his model, and he found a flaw.
Okay.
When he calculated the torque, incrementally taking into account the forces acting on every little piece of the magnet,
Yeah.
that free energy effect went away.
So it was like a mathematical quirk, not an actual violation of physics.
It seems that way.
Okay.
But here's where it gets really interesting.
All right.
Duarte pointed out that commercial finite element method software like COMSOL,
Uh-huh.
which engineers use all over the world,
Right.
still predicted a small net torque in similar magnet arrangements.
Mm.
So that discrepancy raises a big question. Is this just a numerical error in the software?
Yeah.
Or is there something deeper going on that our current models aren't catching?
Okay. Now, I'm really curious what happens next. If it's not free energy, where does Duarte go from there?
Well, this is where things start to get really mind-bending.
Oh.
Duarte starts talking about some radical ideas in his 2019 essay and that 2022 YouTube video.
Like what?
He introduces Einstein-Cartan-Evans theory, or ECE theory.
Einstein, Cartan, Evans. Those are some big names in physics.
They are.
What is ECE theory in a nutshell?
Basically, it's an extension of general relativity.
Okay.
And it suggests that space-time itself
Whoa!
can be twisted and generate magnetic fields under certain conditions.
Hold on, space-time twisting to create magnetism? That sounds incredibly complex.
It is, but the important thing for our deep dive is that Duarte proposes a connection between ECE theory and those vibrations we talked about.
The ones in the magnet motor patents.
Yes, the ones that Malafia and Brady mentioned but didn't really explain.
Right, I thought those were just minor details.
Well, Duarte initially thought so too.
Oh.
but he later came to believe that they might be super important.
Mm.
He suggests that specific magnetic geometries combined with those tiny rhythmic vibrations
Yeah.
could create a type of resonance in space-time itself.
And according to ECE theory, this could allow energy to flow from the vacuum into the motor.
That's his hypothesis.
You're saying these motors might be drawing power from the quantum vacuum, that sea of energy that exists everywhere.
Exactly, and he argues it's not actually free energy
Right.
because it's being tapped from this pre-existing energy source that quantum field theory says exists everywhere.
Wow. So we've gone from classical electromagnetism to twisting space-time and to tapping into the quantum vacuum?
It is a lot to take in.
Yeah, it is, but it's all connected by these tiny vibrations.
It is quite a wild ride.
It is, and it really highlights how even the smallest details can lead to huge scientific insights.
Absolutely.
So we're talking about tapping into the energy of the quantum vacuum.
That's right.
It sounds like something right out of science fiction.
I know it does.
But if I'm understanding this right, it's an actual concept in physics.
It is. It's a core concept in quantum field theory, actually.
Okay, so explain it to me like I'm 5.
Okay, so imagine a perfect vacuum. Even in that emptiness at the tiniest level,
Yeah.
there's a flurry of activity particles and antiparticles popping in and out of existence.
So empty space isn't really empty?
Yep, not at all.
There's this hidden energy field constantly doing its thing.
Exactly, and although it's really hard to measure directly,
Uh-huh.
quantum field theory suggests that it's incredibly dense, like a vast untapped ocean of energy surrounding us.
Okay, so Duarte is saying that these magnet motors might somehow be able to tap into that.
That's what he's proposing, and there's actually a phenomenon called the Casimir effect that shows that this vacuum energy is real.
How so?
Well, the Casimir effect,
Yeah.
fluctuations in the quantum vacuum actually create a measurable force
Wow.
between two really, really close uncharged conducting plates.
So we have proof that this vacuum energy can have real effects.
Yes, the Casimir effect is well documented.
Okay, so the quantum vacuum is this ocean of energy, and we've got proof it can do stuff. But how do the magnet motors fit in? We're not talking about tiny particles here.
Right.
We're talking about big old magnets spinning around.
That's where those vibrations we talked about become so important.
The ones in the patents.
Yes, remember how Duarte said that specific magnetic geometries plus those vibrations could create resonance in space-time?
It's like they're setting up a specific vibration that interacts with reality, like tuning a radio to a specific frequency.
That's a really good analogy.
Thanks.
Duarte thinks those vibrations could be the bridge between the world we see and the microscopic world of the quantum vacuum.
I'm starting to see how it all fits together.
Okay.
So we have the potential energy source, the quantum vacuum,
Right.
and maybe these motors are creating a specific resonance to tap into it.
Right.
But how does that make the motor spin? Where's the actual force coming from?
That's where ECE theory comes in.
Okay, the space-time twisting theory.
Yes. Remember, that theory suggests space-time can be twisted to create magnetic fields.
Yeah, it's still pretty mind-boggling to me.
I know it's a radical concept,
It is.
but if ECE theory is right,
Yeah.
those vibrations and the resonance they create could be twisting space-time around these motors.
Okay.
Imagine it like a magnetic whirlpool that pushes the magnets and makes the motor spin.
So the motor isn't like sucking energy out of the vacuum.
No.
It's creating a condition where the vacuum energy turns into a force that drives the motor.
Exactly.
Yeah.
It's not about pulling energy from nothing. It's about shaping the environment, shaping space-time itself to unlock that energy.
Like setting a sail to catch the wind instead of rowing the boat yourself.
Perfect analogy.
We've covered a lot of ground here, patents with interesting designs,
Yeah.
Duarte's calculations about positive torque and vibrations, and this whole deep dive into ECE theory and the quantum vacuum.
It is a lot.
It's almost too much to process.
I know it's a lot to take in.
It is, but it points to something huge,
Right.
something that could totally revolutionize how we think about energy in the universe.
And we haven't even talked about what it all means.
That's what I want to know. We've talked about the what and the how,
Yeah.
but not the so what. If these magnetic motors actually do what they're supposed to, what does that mean for the world?
The implications are massive, both practical and profound.
Give me an example.
Well, on the practical side, if we could use this vacuum energy even a little bit, it would totally change energy production.
No more reliance on fossil fuels.
Exactly. Imagine powering our homes,
Yeah.
cars, businesses, everything with this energy source that's clean, abundant.
Yeah, and unlimited.
Exactly.
But what about the profound implications?
Ah,
You
yes.
said ECE theory builds on general relativity.
It does is.
And we've been talking about the very fabric of reality.
Right.
So it goes beyond just clean energy.
It touches on something much more fundamental about the universe.
Okay, like what?
If Duarte is right, and these motors are messing with space-time like that,
Yeah.
it would totally challenge our most basic understanding of physics and reality itself.
Like discovering a whole new set of rules that govern the universe.
Exactly, a paradigm shift.
Wow.
It would mean that the energy we've been searching for has been here the whole time, woven into existence itself.
It's like we've been living in this world thinking we knew how it worked.
Right.
But there's this whole other level of reality we're just starting to see.
That's a good way to put it.
And it shows how important it is to be open to new ideas, even the ones that seem crazy.
Absolutely.
So where do we go from here? We've looked at patents and theories and mind-blowing implications.
It's been quite a journey.
What's next in our deep dive? Okay, so we've explored twisting spacetime and the quantum vacuum
Wow.
and these mysterious magnet motors.
Hmm.
I gotta say, it's all very exciting.
Yeah.
I'm still kind of hung up on what this means practically. You know, if these motors can actually tap into this huge energy source, what does that mean for, like, everyday people?
That's the million-dollar question, isn't it?
Yeah.
And to be honest, it's still early days.
Okay.
I mean, we're talking about cutting-edge theoretical physics and experimental engineering here. This isn't something you'll see at Walmart next week.
So we're not all going to be building magnet-powered houses tomorrow.
Not quite.
Okay.
But even if practical uses are years or even decades away,
Right.
the potential is still revolutionary.
Right.
I mean, imagine a world where every house could have its own clean, unlimited energy
Yeah.
from what's essentially a bunch of magnets arranged in a clever way.
No more utility bills, no more fossil fuels, no more worrying about carbon emissions.
Exactly.
It sounds too good to be true.
It does, but that's the scale of the potential we're talking about.
Huh?
Of course, there are still challenges ahead.
Like what?
Well, the scientific community needs to really test Duarte's ideas.
Yeah.
We need more research, more experiments,
Or data.
Exactly. And even if the science checks out,
Yeah.
there's going to be huge engineering hurdles,
To overcome.
right? We'd need to figure out how to make these motors efficient, reliable, and something that can be mass-produced.
Yeah, that makes sense.
Plus, there's the whole economic and social side of things.
Yeah.
A technology this disruptive could completely change industries and, like, global power structures.
Yeah.
It's a big deal.
You're right. It's not all sunshine and rainbows. We have to think about the downsides, too.
No.
You're talking about potentially changing the foundation of our technology and our whole society.
It's huge.
We can't just get caught up in the possibilities we have to think about the ethical, social, and economic impacts of something this big.
Absolutely. It's not just about making a better motor. It's about potentially reshaping the world.
So what can our listeners do to stay in the loop about all this and maybe even contribute?
Well, first things first, education.
Okay.
Dive into the stuff we've been talking about, Duarte's essays, the patents, the YouTube videos.
Mm.
The more you understand the basics, the better you'll be able to, like, evaluate new developments and join the conversation.
What about for the folks who like to tinker and get their hands dirty?
There's a whole DIY community out there experimenting with magnet motors.
Really?
Yeah, a lot of them share their designs and what they find online. It's citizen science at its finest.
It's kind of cool to think someone messing around in their garage could make a discovery that changes the world.
It really is.
Yeah.
But along with those individual efforts, we also need more research funding at a bigger level.
Okay.
Universities, governments, private companies, they all need to get involved in exploring this tech.
The potential payoff is just too big to ignore. I mean, imagine a future where we've figured out vacuum energy. It could be a new era of abundance and sustainability for everyone.
It's a future worth working towards.
Absolutely. Well, I think that about wraps up our deep dive.
It does.
We've explored the science, the engineering, and the mind-blowing possibilities of magnet motors and this whole idea of tapping into the quantum vacuum.
It's been quite a journey.
This topic really makes you rethink what you thought you knew about energy technology and even reality itself.
It does.
We've given you the tools to start your own exploration. Dive into the source material, join the conversation, and hey, who knows, maybe you'll be the one to make the next big breakthrough. Until next time, keep asking questions, keep learning, and keep diving deep.